Hi kids, in this video we'll continue our discussion from exercise 16.3 from class 9, circumference and area of circle. We have already done till sum number 21. Now let us see sum number 22. A student takes a rectangular piece of paper 30 cm long and 21 cm wide. Find the area of the largest circle that can be cut out from the paper. Also find the area of the paper left after cutting out the circle. Pretty easy. First thing, draw the diagram. That will help you to visualize the sum. So this is a rectangular sheet of paper with length 30 centimeter and with breadth 21 centimeter. Now the biggest circle which you can draw inside this rectangle will have the diameter equal to the breadth of this rectangle. Something like this, whose diameter will be equal to 21 centimeter. So we need to find the area of this. See, diameter is 21 centimeter. So the radius will be 21 by 2 centimeter, isn't it? So the area of the circle will be pi r square. So that's 22 by 7 r square. That's 21 by 2 whole square. So that's come as 22 by 7 multiplied by 21 by 2 multiplied by 21 by 2. 7 3 times, 2 11 times, that's 33 into 21 by 2, that's 693 by 2. That comes as 2 3s are, 2 4s are, 2 346.50 centimeter square. Done. That's the area of the circle. Now they have asked, find the area of the paper left. So this portion, isn't it? So area of paper left, if you see, will be equal to the area of the rectangle minus the area of the circle, isn't it? From the rectangle, if you remove the circle, you get that portion. So area of rectangle is what? 30 multiplied by 21. That's 30 multiplied by 21 minus area of circle, we already know, 346.50. So that's 630 minus 346.50, that's 0.50. 9 minus 6 will give us 382. So that's your answer, 283.50. Draw the diagram, it will always be helpful for you. Now 23. A rectangle with one side 4 centimeter is inscribed in a circle of radius 2.5 centimeter. Find the area of the rectangle. Very easy. First, draw a circle. Now they are told you have inscribed. Inside this, there is a rectangle. So something like this. Okay, A, B, C, D. Now the most important thing to remember over here that the diagonal of the rectangle will be equal to the diameter of the circle, which means this rectangle with one side 4 centimeter, suppose this is 4 centimeter, is inscribed in a circle of radius 2.5. So diameter will be 5 centimeter, which means BD is 5 centimeter. Now with the help of, we know this is 90 degree. Now with the help of BC and BD in the triangle BDC, we can get DC. How? See, this is the perpendicular, so DC square plus BC square equals to BD square, Pythagoras theorem. We have already done this, so DC square plus this is 4 square equals to 5 square, so DC square equals to 25 minus 16, that's 9, so DC will be 3 plus minus 3, so we'll take positive. So DC is 3 centimeter. So the area of the rectangle, isn't it, will be length multiplied by breadth, which is 12 centimeter square. Done. Now let us see the next sum. Now look at sum number 24 part B. Very simple. They have given a semicircle with diameter AC and they have given AB and BC are equal, that is 7 centimeter, and in triangle ABC, angle B is 90 degree. They have told us to find the area of the shaded region. Clearly, area of the shaded region is area of the semicircle minus area of the triangle. Area of the triangle is easy, we can get because base and height we know. For the semicircle, we need to know the radius. Now look carefully. In triangle ABC, AC square is AB square plus BC square because it's a right angle triangle. So AC square, which AC is the diameter of the semicircle, just remember that. That's 7 square plus 7 square, that's 98. So AC will be 7 root 2 centimeter. So AC is the diameter, so the radius of the circle is 7 root 2 by 2 centimeter. Correct? Now look, area of the triangle will be half into base into height. That's 49 by 2 centimeter square. Leave it like that. And area of the semicircle will be pi r square, which is 22 by 7 r square, 7 root 2 by 2 whole square by 2, isn't it? Pi r square by 2, which when we solve comes as 22 by 7 multiplied by 7 into 7. Root 2 square is 2. 2 was already there. And 2 square is 4. Am I clear? This, 2 times, 11 times, that's 77 by 2 centimeter square. So area of the shaded will be this minus this. So area of shaded region will be 77 by 2 minus 49 by 2 to take an LCM. 77 minus 49, that's 28. So that's 14 centimeter square. Done. Clear? Now let us look at 25. A circular field has perimeter 660 meter. A plot in the shape of a square. A circular field. A plot in the shape of the square having its vertices on the circumference is marked in the field. Calculate the area of the square field. Very simple. We did a sum like this, you know. It was a rectangle. Over here, it's a square. You have a circular field whose perimeter, which means circumference is given as 660 meter. We can get the radius, okay? A plot in the shape of a square having its vertices on the circumference, which means there's a square whose vertices are on the circle. Okay, on the circumference of the circle. Calculate area of the square field. A, B, C, D. We have just done a sum like this. It was a rectangle where the diameter of the rectangle was, the diagonal of the rectangle was equal to the diameter of the circle. In this case also, the diagonal of the square is equal to the diameter of the circle. First of all, we can say 2 pi r is equal to 660, which means r equals to 660 by 2 pi, which is pi is 22 by 7 goes up. So 11, this is 2 times and 11, 60. This is 2 1s are, 2 30s are, and then 15. So r is 105 centimeter. So we got the radius as 105 centimeter. Okay, so the diameter will be 2 into 105, that's 210 centimeter. Am I correct? So this is 210 centimeter. Now, since ABCD is a square, suppose this side is x, suppose, and this is x, all the sides will be equal. So in triangle BCD, if you see, x square plus x square will be equal to BD square, which is 210 whole square. Am I correct? Which is 2x square equals 210 multiplied by 210, which is x square equals to 210 multiplied by 210 by 2. That's 105. So x square will be 22050. Now if you look carefully, the area of the square is nothing but side multiplied by side, which is x into x, which is x square, and we already got the value of x square. So this is the area of the square, 22050. Now let us look at the next sum. Now look at sum number 26, very interesting. In the adjoining figure, ABCD is a square. Find the ratio between the circumference, number 1. Number 2, the area of the incircle and the circumcircle of the square. Now there are two squares. Incircle, which is the smaller circle, okay, and there is a circumcircle. You can see that's a bigger circle, of course. Okay, bigger circle. Incircle means the circle touches the sides of the square ABC, and circle means the circle passes through the vertices of the square. Now look carefully, just one thing. For the smaller circle, the diameter will be equal to the side of the square. Side of the square. We just need to know this, okay? And for the circumcircle, the bigger circle, we have just done a sum like that. The diameter will be equal to the diagonal of the square. We'll do a proving of this later. In one of the videos, I'll do the proving. How the diameter is equal to the diagonal of the square. Okay? Now look carefully. For the square. For the square. Suppose the side is A unit. Okay? Then the diagonal AC, if suppose this has to lie over here, then AC square will be AB square, which is A square, plus BC square, which is A square. So AC square will be 2A square, which means AC will be root 2 multiplied by A. Am I clear? So for the inner or the smaller circle, if you see, the diameter is equal to AB, which I have taken as A. Okay, so the rear, we can say circumference, suppose this is 1, which is pi d. We have a formula, circumference equals to pi d. 2 pi r or pi d is the same thing, pi into diameter. So that's pi multiplied by A, that's A pi. And for this, the diameter is equal to the diagonal, which is equal to root 2A. So over here, the circumference, which is C2, suppose, okay, over here I've taken, suppose I take a C1. C2 is pi d again, so pi multiplied by root 2A. So therefore C1 by C2, the ratio, see the incircle and the circumcircle. So incircle and circumcircle is pi A by pi root 2A. That is 1 by root 2A, root 2. So the ratio will be 1 is to root 2. Done. Now comes the area. Now A1 is pi r square. Pi r is what? A by 2 whole square. That's pi A square by 4. Done. For this, the area A2, pi r square. So this is the diameter, so the radius will be A root 2 by 2 whole square, which is pi A square multiplied by 2 by 4, isn't it? So if you divide this by this, A1 by A2, if you look carefully, A1 by A2, we need to find the ratio. So 1 by 2 is left. Just see the calculation, which means the ratio of the area will be 1 is to 2. Radius, the ratio of the circumference will be 1 is to root 2 between the incircle and the circumcircle. Clear? Now let us look at the next sum. Now look at 27. Very interesting. The figure given below shows a running track surrounding a grass enclosure PQRSTU. PQRS, which means this is your grass enclosure, isn't it? The enclosure consists of a rectangular PQST definitely, with a semicircular region at each end. So there's a semicircular region. Okay, PQ is 200, so this is 200 meters, and PT is 70 meters. What they've asked? Calculate the area of the grassed enclosure. First, we'll look at the first part only. See, area of the shaded region, which means area of the grassed enclosure, is nothing but area of the rectangle, which is PQST, okay, plus area of two semicircle whose diameters are same, which means area of a circle only. These two semicircle combine to form a circle of diameter 70 centimeter. Isn't it? Just look at the diagram. So area of the rectangle is 70 multiplied by 200, and area of the circle will be pi r square. Pi r, diameter is 70, so the radius will be 35 square. Am I correct? So that's 7 to the 14, 000. This is 22 by 7 multiplied by 35 multiplied by 35. This is 7 5 times. So this is this, and this is 22 into 5. That's 110 multiplied by 35. That is 3850. 3850. Am I clear? So that's, just add it, 17850. That is the area of the grassed enclosure, 17850 meters square. First part is done. Now look at the second part. First part was very easy. Again, there's a rectangle whose area is 200 into 70, and there are two semicircles. You can find the area of the semicircle separately and add it. Or what I've done, the two semicircles, since they have the same diameter, becomes a circle only. Okay. Now, given that the track is of constant width 7, so this part is 7, this part is 7, this portion, okay. Calculate the outer perimeter of A, B, C, D, E, F. A, B, C, D, E, F. Not an issue. C. The perimeter will be AB, which is 200, plus ED, which is again 200, plus the circumference, the outer boundary of this semicircle and the outer boundary of this semicircle, which means, and since, see, for this semicircle EFA, the diameter is 70 plus 14, that's 84. So the radius will be, give it like that, diameter. For BCD, for the semicircle BCD, again the diameter is same, 84. So the outer part of this semicircle and that semicircle becomes nothing but the circumference of a circle with diameter 84, which means plus circumference of a circle with diameter 84 centimeter. Done. So this is 400 plus, this is pi d. We know circumference of a circle is pi d. See, you can do pi d by 2 plus pi d by 2. You can do like that also, or pi r plus pi r, same thing, okay. So that's 400 plus 22 by 7 multiplied by, this is diameter is 84, so that's 12 times. So this is 400, that's 264. That's how much? 664 meter. So the perimeter of A, B, C, D, E, F will be 664 meter. Clear? Now let's look at the next sum. Now look at this sum, 28 part A. Very interesting. There are two circles with center A and B. So for the bigger circle, the center is A. For the smaller circle, the center is B. They touch each other at the point C. If AC is 8, AB is 3 centimeter, find the area of the shaded region. Clearly, area of the shaded region is area of the big circle minus area of the small circle. Now, AC is the radius. AC is the radius for the big circle. Radius of big circle, isn't it? So AC is 8 centimeter, and BC, definitely BC is AC minus AB, which is 8 minus 3, that's 5 centimeter. This is the radius of the small circle drawn over here, isn't it? Just look at the diagram carefully. The area of the big circle is pi r square. R is what? 8 square. Area of the smaller semicircle is pi r square, that's 5 square. So pi taken common, 64 minus 25, isn't it? Okay, so this becomes 939 pi, isn't it? You put the value of pi and get the answer. Done. Now look at part B. The quadrant shown in the figure are each of radius 7 centimeter. Calculate the area of the shaded region. Now you'll ask me, where's the quadrant? Just look over here. If you just draw imaginary dotted line, see. Now I hope you can see 4 quadrants, isn't it? 1, 2, 3, 4. Each of radius 7 centimeter. Now look carefully. Area of the shaded region is nothing but area of the square minus area of 4 quadrant, and all the quadrants have equal radius, which means 4 quadrants will add to give a circle. So area of a square, now this is 7, this is 7. Area of a square is side multiplied by side, and if you look carefully, the side of the square is 7 plus 7, that's 14 centimeter, minus area of 4 quadrant is nothing but area of a circle, which is pi r square. So that's 14 multiplied by 14 minus 22 by 7, r is 7 square. That's 196 minus, this is 22 by 7 multiplied by 49. This is 7 times 196 minus 154. Isn't it? That's 42 centimeters square. Done. Am I clear? Now let us look at the next sum. Now look at 29 part B. Very easy. There's a quadrant O, P, B, D. Inside the quadrant, there's a square inscribed inside it. Okay, O, A, B, C, which sides 20 centimeter. Okay, they've asked for the area of the shaded region. Clearly, area of the shaded region is nothing but area of quadrant, if you look, minus area of the square. Very simple. Now, area of the square is side into side. That's 20 into 20, 400. Not an issue. But when you talk about the quadrant, we need to know the radius. Now, just remember, the diagonal of the square becomes the radius in this case. Isn't it? See the diagram properly? So, OB square, Pythagoras theorem, is 20 square plus 20 square. So, OB square is 400 plus 400, that's 800. So, your OB will be 20 root 2. Isn't it? Keep it like this. And that is the radius only, 20 root 2 centimeter. Done. So, area of the quadrant is pi r square by 4. That's pi r square by 4 minus area of the square will be 20 multiplied by 20. So, that's 3.14. They have told in the sum r square. That's 20 root 2 whole square by 4 minus 400. So, that is equal to 3.14 multiplied by, this is 800, isn't it, by 4 minus 400, that's 200. So 2 4s are 8, 2 1s are 2, 2 3s are 6. So that's 228 centimeter square. Pretty easy. Get the area of the square, get the area of the quadrant, subtract it. The diagonal becomes the radius in this case. Okay? Now, look at the next sum. Now look at sum number 30 part A. Very easy. They've given a rectangle A, B, C, D with BC and AD as the diameter. They have drawn 2 semicircle, okay, which have the same area, of course, because the diameter is same. And they have done another semicircle, you can see, with DC as the diameter. They've asked for the area of the shaded region. Over here, AB is 14 and BC is 7. Now look, area of the shaded region I can write that is equal to area of two smaller semicircle plus area of rectangle minus area of big semicircle, isn't it? If you look carefully. Okay, now just area of two smaller semicircle will be pi r square by 2 plus pi r square by 2, which is nothing but pi r square, isn't it? Pi r square, since the radius is same, okay, because the diameter is same, BC and AD are same. Area of rectangle is length into breadth, that's 14 into 7 minus area of big semicircle will be pi r square by 2, isn't it? Just substitute the value. So that's 22 by 7. R is how much? This is 7 by 2 whole square. This is 98 minus 22 by 7. And capital R is how much? This is 14. That's 7 square by 2. Isn't it? Just do the calculation. That's 22 by 7 multiplied by 49 by 4 plus 98 minus this is 22 by 7 multiplied by 49 by 2. This is 7 times, 11 times, this is 7 times, this is 11 times. 11 into 7 is 77 by 2. That's 38.5 plus 98 minus 77. Isn't it? So that's 38.5 plus I can say 98 minus 77 is 21. Isn't it? Yeah. So that's 59.5 centimeter square. So that's the area of the shaded region. Done. Now let us look at 30 part B. Now they've given a circle. Okay. And there you can see they've asked for the shaded region area. This BOD is a quadrant and COD is also a quadrant. They've given AC as 24, AB as 7 centimeter. Now one thing we should know, okay, there's a theorem which says that if there's a semicircle, okay, suppose XY is the diameter, you draw any triangle with one of the side XY and the other vertex on the circumference, and this is always 90 degree. We'll do the proving later, okay? Remember this for now, which means if you look at triangle ABC, BC is the diameter. Remember this theorem, okay? Okay. Now, ABC is the triangle in which BC is the diameter. So, angle A, according to this theorem, this is angle at a semicircle. Angle at a semicircle is always equal to 90 degree. We'll do the proving. I'll make a video on this later. So, now it's very easy. See, AC is 24, OAB is 7. So we can get BC first. Of course, BC is the hypotenuse. So BC square is 24 square plus 7 square. That if you add them square and add them, that's 625. So BC will be 25. No doubt in that. Once you got BC as 25, we know the radius will be 25 by 2. Okay, so area of the shaded region is nothing but area of the circle, okay, minus area of the triangle minus area of the quadrant. Area of quadrant, isn't it? So area of the circle is pi r square. So BC was 25. So radius will be 25 by 2 whole square. Area of the triangle is half into base into height. So the base is 7 and the height is 24. Minus area of the quadrant is 1/4 the area of the square. That's pi r square by 4. If you do the calculation, you can get the answer easily. So keep it till here in this video. In the next video, we'll see the rest of the sum and finish this exercise. Till then, take care.